Hello students, welcome to Eshwari Thaniksha channel. Students, in this video I'll be teaching a super trick to solve the questions easily which is given in equilibrium. So students, the types of question which can be asked in equilibrium is either to calculate Kp or Kc. So what you have to keep in mind is first about temperature and then R value. So temperature usually it will be given in degree Celsius or it will be in Kelvin scale. So always when it is given in degree Celsius, don't forget to convert it to Kelvin scale. If it is given already in Kelvin scale, then you can use as it is. Coming to R value. R value you have 0.0821 liter atmosphere per Kelvin per mole, or you have 8.314 joule per Kelvin per mole. So which R value to use? So students, you know that in Kp, that is in terms of pressure, and this is in terms of concentration. So pressure will be in atmosphere and concentration will be in terms of moles per liter. So that is why we have to use this. Use 0.0821. For example, I'll show you for example. See, if you have PV is equal to nRT, ideal gas equation. So in this you have, suppose I'll put some value, N is 2 into R value, I'll take this 0.0821 into temperature. So temperature I'll take in Kelvin scale, I'll take 720. So now this you have to multiply in order to get the value of PV. So students, it will take again time to calculate this. So usually in NEET examination what happens is 99% of the students what they do is multiply everything and then waste the time. So if you have to score more than the other, you have to use some tricks to calculate this easily. So I'll show you one trick to calculate this easily. So how to calculate is, instead of 0.0821, here you can use this value is approximately equal to 1 by 12. So in place of this, substitute 1 by 12. So see here you will be getting 2 into 1 by 12 into 720. So now cancel this. 12 ones are 12, 12 6 are 72. So 60. So this is equal to 6 2s are 12. So you will be getting 120 as the answer. See how much time is consumed in this. So still if a bigger number is given, so it takes lot of time for you to multiply and get the answer. So instead of that, if you use this value, so within few seconds you will be getting this. I'll show you how to use this value in a problem also. I'll take one numerical and I'll show you how to use this value. So let us solve this numerical using the trick. First, write what is given in the question. So first let us write what is given in the question. 184 grams of A is heated. So 184 gram mass is given. Mass is equal to 184 grams at 327 degrees Celsius. Convert to Kelvin. So temperature is equal to 327 plus. So you have to add 273 to this. So which is equal to 600 Kelvin. In 20 liter container, volume is given as 20 liter. Total pressure is given as 6 atmosphere at equilibrium. So total pressure is given as 6 atmosphere. And then molecular mass is given as 92. So molecular mass of A is given as 92. What you have to find? You have to find Kc and Kp. So simple trick I'll show you how to get. So the equation which was given is A giving 2B. So this is the equation which is given in the question. Both are in the gaseous state. So first what you have to do is you have to find the pressure of A. In the question they have given total pressure, but we have to find the initial pressure of A. How to find is use ideal gas equation, PV is equal to nRT. So P is pressure of A. PA is equal to nRT divided by V. So this is equal to, what is N? N is number of moles. So here you check number of moles is given. It is not given. So you have to find out. So number of moles is equal to mass by molecular mass. So mass is given 184. Molecular mass is given 92. So cancel this, you will be getting 2. So number of moles is 2 into R value. R value is 0.0821 into temperature. Temperature is 600 Kelvin divided by volume. Volume is 20. So students, see here, first you have to multiply 2 into 0.8021 into 600 divided by 20. So it consumes lot of time for you. So that is why I told you to use the trick. So what is the trick we are using? Instead of 0.0821, we will be using 1 by 12. So now substitute 1 by 12. 2 into 1 by 12 into 600 divided by 20. So now is it simple to cancel? 12 ones are 12 fives are 60, 0. 1 0 1 0 gets cancelled. 2 gets cancelled. So you will be getting 5 atmosphere as the answer. See how simple it is. So now we got pressure of A. So now I'll write once again the equation, that is A giving 2B. This is the equation. So now what you have to do is write stoichiometric coefficient. So stoichiometric coefficient of A is 1, B is 2. So you have to write the coefficient, numerical coefficient. This is 2, and here A, if there is no number, means you have to write it as 1. Now when T is equal to 0, what is the pressure of A? We have calculated 5, and B will be 0 initially at equilibrium. So at equilibrium the pressure will be, for 1 mole it will be X. For 5 it will be 5 into X, 5X. So you have to write 5 minus 5X. And for 2B, what will be the pressure? You have to multiply this. 5x into 2 is 10x. 5x into 2 is 10x divided by 1. So stoichiometric coefficients you have to multiply. 5x into 2 is 10x divided by 1, you will be getting 10x itself. Now find total pressure at equilibrium. So total pressure is equal to, add all this, 5 minus 5x plus 10x. This is equal to how much? Minus 5x plus 10x will be 5x. So you will be getting 5 plus 5x. So total pressure is given here as 6 atmosphere. So 6 is equal to 5 plus 5x. So x value, how much you will get then? 5x is equal to, so now bring 5 to the other side, you will get 6 minus 5 as 1. So x value you will be getting 1 by 5. So which is equal to 0.2. So x value we got it as 0.2. Now substitute in this. So pressure at equilibrium. So 10 into x value is 0.2. So 10 into 0.2 is how much? So 10 2s are 20, 2.0. So this will be 2. Same way, multiply with this. 5 minus 5x. 5 minus 5. X is 0.2. 5 minus 5 2s are 10. So you will be getting 1.0, which is 1. 5 minus 1 is 4. So this value is 4. So now let us find Kp first. Kp is equal to, so how you will write the expression for Kp? So I have already made a video how to write the expression for Kp and Kc. If you don't know, you can watch that video. Here also I'll show you how to write Kp expression. Kp is equal to, write the pressure of product. So product is B, and if any coefficient is there, you have to rise to the power of that number divided by pressure of A. So this is equal to, So pressure of B, how much we are getting? So see here, at equilibrium we are getting the pressure of B as 2. 2 and here square divided by. So pressure of A, how much we got? 4. So 2 square is 4 divided by 4, you will be getting 1. So Kp is 1. So now how to find out Kc? It is very simple. If you get the value of Kp, it is very simple for us to get the value of Kc. How? You have expression Kp is equal to Kc RT to the power of delta N. So what is delta N? Delta N is the number of moles of gaseous mole minus gaseous reactants. So here, so first we'll find delta N. So delta N is equal to number of gaseous mole of the product. So how many moles of products are there? 2 moles. 2 minus reactant 1. So 2 minus 1 you will be getting 2 minus 1 you will be getting 1 as the answer. So delta N value is 1. So substitute here, Kp value we got 1 is equal to Kc into RT, delta N we got 1. So 1 is equal to Kc. So R is gas constant. So again we will write gas constant as 1 by 12 into temperature is 600. So 12 ones are 12 fives are 60, 50. So 1 is equal to 50 into Kc. Then what will be Kc? Kc is equal to 1 by 50. So bring 50 to the denominator. This is Kc. And this is the value of Kp. So is that very simple, students? So use the trick always in NEET examination so that in a short period of time you can solve the questions, so that you will get much time to solve other questions. So if you like the video, you can share with your friends. I'll meet you in the next video, students. All the very best.